Good morning. I hope we're all well, we're staying safe, and we have done all of our work so we can have a nice Easter break. I just wanted to upload this video now in case any of you wanted to mark your work from last week. It will be part of the lesson that is going to be set for the first week after Easter, so don't worry if you don't want to do it now. But I thought I'd get it in place. So as part of the lesson you were asked to complete this sheet, so I'm going to go through this sheet with you now and basically fill in each of the boxes, and all I want you to do is just purple pen anything that you may have missed. The idea of this sheet was that it was a revision sheet bringing together everything we've done about the global atmospheric circulation. So hopefully you've managed to put out the key points, the key words, things like 60 degrees north, 30 degrees north, all of that kind of stuff, and then just add anything you have missed. So the first question up here is, what is global atmospheric circulation? Okay, so global atmospheric circulation is the worldwide system of winds. That's what's important there. It's the worldwide system of winds. Okay, so you're talking about, these are all currents that are created by wind. Okay, so it's the worldwide system of winds which transfer heat from the tropics to the poles. You may have got a slightly different definition, but make sure the key thing there is that it's about the wind. Now for this one, the air pressure found at D, so D is here, so you should have got that it's rising, so it is low. E is here, it is sinking, so you should have got that it is high, and then F is low and G is high. So just remember, low pressure, your air is rising, high pressure, your air is sinking. Okay. Why does air subside at the poles? Now subside just means sink. Okay, so if you didn't understand what that word meant and you want to make a little note to yourself, put sink. Okay, so it sinks because your solar intensity is so low. So solar intensity is low, which we know at the poles we don't get lots of solar intensity. So you get cold air, and we know that cold air sinks. Okay, so that is why that happens at the poles. How do temperature and rainfall change as moving from the equator to the poles? There's two things here, temperature and rainfall. So hopefully the easiest one was that you should have said temperature, I'm just going to put a little arrow, decreases. Okay, that should have been easy. Temperature from the equator to the poles goes down. Rainfall is a bit more complicated, but actually it also goes down. So it also goes down. So they both go down. The difference is that rainfall is a bit more complex, as we have high, low pressure areas. Okay, so the actual amount of rainfall does decrease from the equator. So this is where you get most of the rainfall. So this is the highest amount of rainfall. Even though you've got rainfall here, it is not as high as here. Okay, so this is the highest, and by the time you get to the poles, it is the lowest. However, it is more complex because it goes high, low, but this is not as high as this, so it does still go down. Describe the location of high pressure systems. All you have to do is tell me where they are. So they are 30 degrees north, 30 degrees south, and at the poles. That's all you had to do was in that one. Okay, so give yourself kind of tick if you got those. If you missed any, please write them in. Lots of people forget to actually use these, so they might have written Tropic of Cancer, Tropic of Capricorn, which is brilliant, but please use the numbers. And lots of people leave out the poles completely. They learn this Hadley cell and forget that we have this polar cell up here as well. So poles as well. Describe the location of low pressure areas. So this is the equator, or you might have put the ITCZ, okay, because obviously we know that. And it is also 60 degrees north and 60 degrees south. Okay, I'm going to go up here now. Why is there a heat surplus? Now this just means you've kind of got excess. Okay, so you've got extra heat. So why is there extra heat at the equator is what it's asking. Okay, so the reason why, as you should know, is that the heat on Earth is uneven and more concentrated at the equator. So you get more at the equator. Identify 2 ways heat from the equator is moved towards the poles. Now the 2 is the bit that you might have found tricky here. Okay, I'm guessing you all would have put atmospheric circulation. The one you may have forgotten is your ocean currents. Now I'd forgive you for that. That was our very first lesson, our very last lesson. So atmospheric circulation and ocean currents. Don't forget ocean transfers heat as well. It's not just about this model. This model is to do with the wind, but it's oceans as well doing the job. The cells, hopefully this was easy. We have Hadley, we have Ferrel, and we have Polar. Hopefully that one was super easy. How do ocean currents transfer heat? Now this was the last lesson we did. Okay, so if you remember, about 20% of heat from the tropics goes to the poles. And this is because you have these convection currents in the ocean caused by sinking cold water pulling down warmer surface water. Why is there little rain associated with high pressure? So what you should have got here is that the air is sinking, so prevents clouds forming. Okay. Explain 2 ways heat is transferred from the poles equation. I think explain's a bit mean here because actually you probably just needed to state them. Okay. So again, you could have had ocean currents, okay, and your atmospheric circulation. Now it's the same question as this one up here. This one says identify and this one says explain. Now I don't think there's enough space in that box to explain, but basically you needed to be able to say how ocean currents transfer heat, which if you've done this right, you've already done, and then how atmospheric circulation transfers heat. Okay, so for this you need to say that it is the wind moving from high to low pressure, okay, transferring the heat. Okay, so that is this sheet. Okay, please purple pen anything, watch it as many times as you need to make sure you've got all of the key information, and please ask me if you have any questions. I will upload your next piece of work after the Easter holidays. Okay, so have a nice break. You'll notice on the links I've also put on some Netflix programs and some audiobooks. If you do happen to be bored and you want something to get on with, that is something you could do. Hey, have a lovely Easter, guys. Hopefully speak to you soon.